Hello, everyone. My name is Aalian Naviwala, and today I will be presenting my software engineering semester project, the AI Learning Assistant. The purpose of this project is to develop a web-based application that uses artificial intelligence to help students study more effectively. Throughout this presentation, I'll discuss the project overview, the system requirement specification, the software design document, and the software test document, and finally provide theoretical demonstration of how the completed system is intended to work. The AI, the AI learning assistant is designed to make studying more interactive and efficient for students. Its primary purpose is to allow users to upload PDF study documents such as lecture notes or textbook chapters, and then interact with those documents using artificial intelligence. Instead of manually searching through hundreds of pages, students can ask questions about the upload material and receive AI-generated answers. The application also includes additional learning tools such as automatic summaries, quiz generation, flashcard creation, and a progress dashboard that helps users monitor their learning over time. Okay, the software requirement specification, or SRS, defines what the system is expected to do. It defines both the functional and non-functional requirements of the application. Some of the major functional requirements include user registration and login, uploading PDF documents, asking AI questions, generating summaries, creating quizzes and flashcards, and viewing progress through a dashboard. The SRS also defines several non-functional requirements, including performance, security, and usability. These requirements ensure that the application is responsive, protects user information, and provides an easy-to-use interface. After defining the requirements, the next step was designing how the system would be built. The software design document describes the overall architecture and the technologies that will be used. The application follows a client server architecture using layer design and the model view control pattern. The front end is planned to be developed using React, while the backend will use Flask. PostgreSQL will store user data and application data. ChromaDB will manage document embeddings for retrieval, and the Google Gemini API will provide the AI capabilities for answering questions and generating study materials. All right, here is the component diagram. All right, component diagram provides a high-level overview of how the different parts of the system will interact. The user will with the user interacts with the React frontend through a web browser. The front end communicates with Flask backend using REST APIs. The backend is responsible for handling authentication, document uploads, and AI requests. The backend also communicates with PostgreSQL to store user information and uploaded documents, with ChromaDB to retrieve relevant document content, and with the Gemini API to generate AI response. The separation of components make the system modular and easier to explain. Like here we have the user, they log in, they upload a document, delete it, whatever. They can generate a quiz, flashcard, do a quiz attempt, they'll score the card to them. You can also do a chat session, all that. Here we have the use case diagram. This use case diagram shows the primary interaction between the user and the system. The user, they can, register an account, log in, ask the AI questions, generate summaries, generate quizzes, flashcards, track progress, and monitor it all through the dashboard and, log out. These use cases correspond directly to the functional requirements that were specified in the software requirements specification document. Here we have the class diagram. The class diagram illustrates the main classes used in the application and the relationship between them. Examples include the user class, document class, quiz class, flashcard class, and AI service class. Together, these classes represent the core objects that manage user information uploaded study documents and AI generated content and progress tracking throughout the application. And here is an example. We have the document, class. As an example, they select a PDF, upload PDF, extract text content, they embed it, they store it in the database. It says success shows and upload complete confirmation to the student. All right, here we have the sequence diagram. This sequence diagram demonstrates what happens when a student asks a question about an upload document. First, the user submits a question to the front end, and the front end then sends it to the Flask back end. The back end then retrieves content, the most relevant information from ComaDB, and sends the context along with the user's question to the Gemini API. Open chunks here, here, here. And then Gemini generates a response, which is returned to the backend, which is then displayed to the user in the front end. The process also allows the AI to store to answer the question based specifically on uploaded study materials rather than providing general responses. It also can save the chat for future info. The software test document outlines the strategy that will be used to verify the functionality and quality of application. The testing plan includes unit testing, integration testing, and system testing. Planned test cases cover features such as user registration, login, PDF uploads, and document management, and AI question answering. Since implementation is still in progress, these tests have not yet been executed. Once the once the project has been developed further along, the test will run, the results will be recorded, and any issues that come up will be addressed and fixed. But as of now, at this time, the project is still under development, hasn't undergone these tests. All right, so as I said earlier, like since implementation is still in progress, I'll just demonstrate the intended workflow of a completed application rather than a live software demonstration. So here we have a diagram which represents what would happen in the main project once it is developed to this point. But yeah, so I'll just start off here. The process begins when a student either registers or logs into the system. After logging in, the student can upload a PDF containing lecture notes, textbook chapters, or other such study material. The back end then processes the uploaded document by creating searchable embeddings using ChromaDB and preparing the content for AI retrieval. Once the process is complete, the student can ask questions about upload of the upload material. The application can also provide additional study tools by generating summaries, quizzes, or flashcards based on the same document. Finally, the students' quiz results and learning progress are displayed on the dashboard so that they can monitor their understanding over time. And the next phase of the project is implementation. This includes completing both the front end and back end, integrating Gemini API, finalizing PostgreSQL, ChromaDB databases, and executing the planned test, and deploying the application as a fully built-in web development system. These steps will transform the current software design into working application. In conclusion, this project demonstrates the complete software engineering process from requirements analysis through system design and testing. The software requirement specification defines what the system should accomplish. The SDD explains how it should be built. The SDD provides a structured plan for verifying the application functionality. Although implementation is still in progress, these documents provide a solid foundation for developing this project in this future. Thank you for your time, and I hope you have a wonderful day.